Okay, boiling point. What is a boiling point? Well, of course, that would be the temperature at which something boils, like water. In the last video, we talked about that would be 100 degrees Celsius. Now, that depends on a number of things there, though, as well. So, the boiling point we are going to say is the temperature at which the pressure of the vaporized liquid uh, equals the atmospheric pressure. Now, remember that we talked about vapor pressure. When water vaporizes, it kind of pushes up into the atmosphere, and there's sort of a push of war going on there. And then you have air pressure pushing down, which is a combination of whatever's in the air at the time. This graph that we're looking at here then tells us something about that vapor pressure as a function of temperature. So as the temperature of the water goes up, the vapor pressure also goes up on there. Now, when that vapor pressure equals the atmospheric pressure, which normally is 101.3 kPa approximately, depending upon the altitude and the weather on that day. So at 101.3 kPa, the normal boiling temperature is 100 degrees. So we say the normal boiling temperature is 100 degrees Celsius. That's at a normal air pressure of 101.3 kPa. Now, notice that if the pressure goes up, like on a high pressure day, or goes down, or if you go up in altitude, your pressure goes down, and if you go down in altitude, your pressure goes up. So the temperature at which water boils can fluctuate a little bit because the air pressure can fluctuate a little bit on there. All right, so the temperature at which water boils is not always going to be exactly 100 degrees Celsius. Depends on a number of things. Well, it depends on the air pressure or atmospheric pressure. It also is going to depend on if there's any stuff mixed in with the water, but that's a whole nother matter we'll take up in a different unit. Now, take a look at this pot right here. This is a special kind of cooking pot called a pressure cooker. A pressure cooker. When notice that it has this lid that can kind of clamp on tight. Normally with a pot you wouldn't want to do that, because if you clamp the lid on tight, as it starts to heat up inside there, the pressure will build up and it literally could explode. However, on this particular pot, there's a pressure valve that'll tell you what the pressure is inside, and there's a pressure release valve, or rather a pressure gauge and a pressure release valve. All right, so that it doesn't reach a point where it will actually explode. Now, what would be the purpose of such a pot? If you increase the pressure above the liquid, okay, there's liquid inside this, and the pressure starts to build up above it, that's going to affect the temperature at which the water boils. All right, remember how this works? As the vapor pressure, as the temperature goes up, the vapor pressure goes up, and when the vapor pressure equalizes the pressure above it, which is going to grow in here as this gets hotter and hotter, the water will boil at a higher temperature. So if we can increase the pressure, normally at atmospheric pressure 101.3 kPa, but if I can increase the pressure inside there, then we can make the water boil at a higher temperature. So that is the purpose of a pressure cooker. It allows you to cook with a temperature that is higher than the normal boiling point. And the higher the pressure that you make, the higher that temperature can get. And it could get pretty high if you let the pressure get really high on there. So normal cooking in a kitchen, you wouldn't have to go too high there. But if you wanted to, like, say, sterilize stuff in places like doctor's office and dentist's office, they will actually do that. They have a special device called an autoclave, which basically does exactly that. It heats stuff at a very high temperature to sterilize it, kill germs, bacteria, and stuff like that. And they use such a thing, but they call it an autoclave, but it's essentially the same thing. All right, question. What does pressure have how does pressure affect boiling points and melting points? All right, what we just looked at there is the fact that as pressure goes up, boiling temperatures also go up. That's what a pressure cooker does. Now, as pressure goes down, then the boiling temperature will also go down in the other direction. So if the pressure above the liquid we're trying to boil changes, it can affect the temperature at which it boils. Now, a similar thing happens on the other end when you melt or freeze stuff. If you increase the pressure, you will make water freeze at a lower temperature. You can make water freeze at a lower temperature. This is what happens when sometimes we say when you stand on ice, with some ice skates, the pressure underneath the skates is very, very high because the surface area is small. Right? The pressure can literally get so high that it decreases the temperature at which the ice melts, and right underneath the skate will be a real thin layer of melted ice underneath that. If you were to literally stand in one spot on the ice for a long time, you probably would sink right into the ice as the ice is being melted underneath your skates like that. Another time you see such an example, if you ever took like a bottle of pop with a cap on it and then you put it into a freezer, eventually it'll get really cold, but because the pop is pressurized, it won't freeze until it gets a colder temperature than its normal freezing temperature because the increased pressure inside of that. If it gets to the point where it almost is frozen and you release the pressure, suddenly the whole thing will turn into ice. All right, maybe I'll try to freeze a bottle of pop and we'll see how that works. All right, got one last question for you. The atmospheric pressure on Mount Kilimanjaro is 275 millimeters mercury. Now, it depends on the day too, of course. Now, here's Mount Kilimanjaro right here. This is a famous mountain in the country of Tanzania in Africa, on the African continent. All right, Mount Kilimanjaro, like that, very famous mountain there. If you were to climb to the top of that mountain, the air pressure is much, much lower. All right, it's much, much lower. So that's actually going to have an effect on the temperature at which water boils. So how could we determine that? What we would need is that graph. All right, what we would need is that graph. Now, the first thing we would have to do here, because our graph is in kPa, kilopascal, and this pressure given here is in millimeters mercury, so we have to make a conversion. All right, so 275 millimeters mercury, and we're going to convert that into, let's say, 760 millimeters mercury is equivalent to 101.3 kPa. All right, that conversion factor you get on the test, and then we can convert our millimeters mercury into kPa. All right, let me grab a calculator and punch that in there for you. 275 times 101.3 divided by 760, I get 37.1 kPa. Then I can look at the graph. 37.1, there's 30, 40, 37, so somewhere right around there. So what temperature does water boil at on the top of Mount Kilimanjaro? Because the pressure is so low, it looks to me like about 75 degrees Celsius. 75 degrees Celsius. Much lower than the normal temperature of 100 degrees. All right, so people that live at high altitudes, they often will have a pressure cooker, because if you try to cook something like spaghetti at a low temperature like that, it's going to take a long time. Might not even cook. So a lot of times people that live at high altitudes actually have a pressure cooker because it increases the boiling temperature of water. All right, thank you.